Welcome to question 10 of the 2012 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So let the function f have a domain of all real numbers with a rule f of x equals e to the power of negative mx plus 3x, where m is a positive rational number. For part A, part 1, we want to find in terms of m the x-coordinate of the stationary point of the graph of y equals f of x. And now if we want to calculate stationary points, we need to calculate the derivative f dashed of x is equal to 0. So the derivative of e to the power of negative mx is going to be negative m e to the negative mx. The derivative of the plus 3x is just plus 3, and we want to solve that equal to 0. So therefore, if we were to subtract 3 from both sides, we'd have negative m e to the power of negative mx is equal to negative 3. And then we would have e to the power of negative mx is equal to negative 3 on negative m is 3 on m. And now to solve for x, we need to put this in an equivalent log form. So the base of the log is going to be e, so we're going to have log e of 3 on m is equal to negative mx. So therefore, x is going to equal negative 1 on m times log e of 3 over m. So that is the answer to part 1 of part A. For part 2, we want to state the values of m such that the x-coordinate of this stationary point is a positive number. So we know the x value of the stationary point was found before to be negative 1 on m log e of 3 divided by m. And now it's actually more useful to use a log law that says if we have a number out the front, we can bring it up as a power of the argument. So we're going to write that that's equal to positive 1 on m times log e. And instead of having 3 on m to the power of negative 1, that just flips the fraction, so we'll have m on 3 inside the log term. And now we want this term to be greater than 0, so that will give us a positive number. So we're going to continue this question by sketching a quick graph of log e of x. So that's the graph, and it's got an asymptote here at x equals 0. And we know that the x-intercept is at 1, 0. So these are all positive values that come out of the log function, and that's when x is greater than 1. So the rule that we're dealing with over here is a little bit more complicated than log e of x, but because m is a positive number, 1 on a positive number is still going to be positive out the front. So all we need is the part inside this log function to be greater than 1. So let's write that down. So we have m on 3 must be greater than 1. So therefore, multiplying both sides by 3, we find that m must be greater than 3. So they are the values of m such that the x-coordinate of the stationary point is a positive number. So from the examiner's report, we can see that 56% of students got part 1 of part A correct, with most students differentiating correctly and equating the derivative to 0 in order to find the x value of the stationary point. For part 2, only 18% of students got the correct range of values of m, and the examiner went on to state that understanding the restrictions within the logarithm caused difficulty for many students. So that is, they couldn't identify what values went inside a log to give a positive value out overall. For part B of the question, we have for a particular value of m the tangent to the graph of y equals f of x at x equals negative 6 passes through the origin, and we're asked to find the value of m. So to do this question, we're going to exploit a property that y2 subtract y1 over x2 subtract x1, so the gradient between 2 points, is going to be equivalent to a derivative f dashed of x at a value. So if we have 2 points that lie on the tangent, and the derivative can be used to calculate the gradient of a tangent, we can create an equation to solve. So firstly, we're going to find the function's value when x is negative 6. So plugging that into the rule, we get e to the power of negative m times negative 6 is going to be e to the power of positive 6m. And then we have plus 3 times negative 6 gives negative 18. So therefore, we know the point where the tangent is going to be negative 6 comma e to the power of 6m minus 18. And next we're going to calculate the derivative's value when x is negative 6. And we found the derivative before. It was negative m e to the power of negative mx. So when we put x is negative 6 in there, we get negative m e to the power of 6m. And then we just had plus 3. So that's the value of the gradient of the tangent line at negative 6. And now, with the fact that it passes through the origin, which has coordinates 0, 0, we can calculate the gradient of the tangent line between 0, 0 and negative 6 e to the power of 6m minus 18, so those 2 points, and let that equal the derivative's value when x is negative 6. So that's a lot to keep track of, so let's write it down. We're going to use y2, which is going to be e to the power of 6m minus 18, minus y1, which is 0 because it passes through the origin, divided by x2, which is negative 6, subtract x1, which is 0, and that gradient there is going to equal the gradient of the tangent line, which is negative m e to the 6m plus 3. Next, we're going to multiply by the negative 6 in the denominator, so we get e to the power of 6m minus 18 is equal to positive 6m e to the power of 6m minus 18. And then we can get this equation equal to 0, so we have e to the power of 6m, and then adding 18 to both sides, that will cancel the 18s, and we'll just have minus 6m e to the power of 6m could equal 0. Then we're going to factorise that to let it equal 0, so we're going to take e to the power of 6m out as a common factor, leaving behind, and just be careful here, it's 1 subtract 6m, and that could equal 0. And now the null factor law says that e to the power of 6m could equal 0, or we could have 1 take 6m equals 0. However, there is no solution to e to the power of 6m equaling 0. So therefore, the only solution we have is that m must equal 1 over 6 when we solve the second equation. So that is the value of m such that the tangent to the graph of y equals f of x at x equals negative 6 passes through the origin. Now from the examiner's report, we can see that 22% of students got full marks for this question, and that the examiner goes on to say that the most common mistakes were involved in substitution and the algebraic manipulation involved in this question. Most students made a start on this question, although many confused m, a parameter in the question, with the common use of m for gradients in the line y equals mx plus c, and attempted to solve an incorrect equation.